So here are the answers to the second part of that, and I put in the calculator work for those. I happened to pick something for the natural log. I just wanted to try something slightly different. But looking at the calculator results, you can see that they're pretty close here. We're getting pretty close to the actual estimate. Now, does that always happen? No, not necessarily. However, if it's centered closely to the value we're trying to estimate at, it will work. How accurate are our estimates? Well, it all depends on what accuracy we need, right? For our purposes, it's pretty accurate if you see that. As long as you're centered, if you start drifting away from the center, if you start looking at, for example, the earlier functions that we had before, we had the cube root function. There was one at 64, and then the next one up here is at 1x is equal to 125. That's where there's a perfect cube, and it's x is equal to 64. When I'm in that area in between here, my tangent lines are going to be pretty accurate in terms of what values I find estimates for. The only place that we start running into a little bit is where it gets a little steeper, or a sudden change. Like it's more the curvature. The more curvature that there is in the function itself, the less accurate it's going to be. So like if you can imagine, I'm going to make it really extreme. Let's see here. If it curves a lot, oof, and then we're further away from the actual values if there's a lot of curvature of the function. So here are these values from the tangent line to the function gets longer. And the further you are away from the center point, so the value that was easy to find the derivative at, the further we drift left or right, the more inaccurate it gets. So eventually there are places you can, or ways you can calculate error and how far away and what's reasonable. For our purposes, most of it is reasonable. The only place you have to be watchful is when the derivative turns out to be 0 at a value. Then you may not want to use that center point there, because you're going to get a constant, like it's going to be a horizontal line. So the estimate is going to be the same for every value along that. So that's where you would run into trouble. So are all functions created equal? Well, if it has much more curvature, the accuracy is going to go down. And if you drift further left and further right from the center, so the further the distance from the center point determines the accuracy of our estimate. So these are the things you have to keep in mind, right? So is this the cube root? We did the cube root of 68 in the exploration at the beginning. That's going to be a more accurate estimate than the cube root of 70, for example, or the cube root of 75. Any of those, the further I drift away from the center point, it becomes less accurate. What does the accuracy depend on? Like I said, I think I discussed all three things. So how accurate were our estimates? They were pretty good. All functions are not necessarily created equal, because if they're more curved, then they're less accurate, but they're still going to be, if you zoom in close enough, right, they're still going to be fairly accurate. And the drift from the center also affects accuracy. So it's how far are we from the center value that we chose, how much curvature does the function have is also, and you have to, when the derivative turns out to be 0, some strange things can happen. The same if you have a vertical tangent line at a certain center point, obviously that's not going to be a good choice either, because you can't write the equation of a tangent line and use it to estimate. So there are some issues here and there.